Okay, so how to do scale drawings to find out the size of a resultant force. So over here I've got a box. On this box there are two forces. There's a 100 Newton force and a 60 Newton force. Now, this is quite a difficult question to ask, what's the size of the resultant force, because they're not both acting in the same direction. If they were both acting that way, you just do 100 plus 60 to get 160. Or if the 100 one was that way and the 60 one was that way, you'd do 100 minus 60 to get 40. But that's not the case here, they're working at different angles. So what we've got to do is we've got to try and make a parallelogram. A parallelogram is the shape that looks a little bit like that one. One that looks a bit like that. So we're going to try and make something that looks like that. What I'm going to try and do is I'm going to take this 60 Newton force and I want to basically draw this arrow on the end of this arrow. I can do that because forces are vectors. They're not scalars, they're vectors. So I can take the arrow and move it along that line to see where it's going to end up. So what I want to do to be able to do that, I first of all need to measure this angle here. So I'm going to take my protractor, I'm going to line it up there, and I'm going to measure that angle. And I can see there it says 36 degrees. So I'm going to write 36 degrees in there. The next thing I'm going to do is I'm going to measure the length of each of these force lines. So in fact, if I write up my steps up here, step 1 is measure angle. Step 2 is measure length of forces. So I'm going to measure the length of this one first, and it is equal to 10 centimeters. I'm going to measure the length of this one, and hopefully you can see that one is equal to 6 centimeters. And then I'm going to go to the end of this line, and I'm going to measure that angle again. I'm going to measure that angle of 36 degrees over here. So I'm going to put that there. I'm going to make sure this line is lined up with that bit there. And I'm going to measure up by 36 degrees, so just there. And do a little dot. Then, because this line was 6 centimeters here, I want to make sure the line I draw on the end of this is 6 centimeters as well. So remember, this force is 36 degrees there and 6 centimeters long. So if I draw it on the end of here, it has to be 36 degrees there and 6 centimeters long, the same thing. So I've measured the angle in. I'm now going to draw it so I know it's 6 centimeters long, up to there. And that is my 60 Newton force done again. To work out the resultant force, well, I add them both together. I add those forces together. So I'm going to start at the beginning. I'm going to put my pen to where the forces began on the object. I'm going to line up my ruler so it goes from that very beginning to the end point I've just drawn. I'm going to draw a line. This is my resultant force. So I didn't write my steps there. My step 3 would have been draw forces on top of each other. What I mean by that is that I took this 60 Newton force and drew the beginning of the 60 Newton force on the end of the 100 Newton force. Then I draw a line from beginning of forces to end, and that gives you the resultant force. Now I want to work out the size of that resultant force, because that's what this question is all about. So to work out the size of it, I'm now going to measure the length of that line. So that line looks like it's about 15.4 centimeters. So I get this line as being equal to 15.4 centimeters. Now that's fine, that's the length of it, but I need the size of it. So that means, size means measure it in newtons. Well, I know from here that 100 newtons is 10 centimeters. 60 newtons is 6 centimeters. Hopefully you can figure out that each centimeter is worth 10 newtons. If you don't see that, what you do is you divide that number by that number. I do that divided by that. So I'll do 60 divided by 6 will equal 10. I then take this number, 10, and I times it by the size of my resultant force, 15.4 So we equal 154 newtons. Bing bang bosh, 4 marks in the bag.